Welcome back, everyone. Today's lesson will start with some more trig formulas, the double angle formulas. These are also on your reference sheet. The first is sine of 2a, and that's equivalent to 2 times the sine of a times the cosine of a. Cosine of 2a has 3 different equivalent expressions, and once again you're going to have to pick the one that works best for the problem that you're given. So cosine of 2a equals cosine squared a minus sine squared a to cosine squared a minus 1, or 1 minus 2 sine squared a. And finally, the tangent of 2a equals 2 times the tangent of a over 1 minus tangent squared a. Let's look at some examples of how we will use these formulas in a problem. So given that sine of x is negative 3 over 5 between 180 degrees and 270 degrees. So at this point, you should be checking that your calculator is in degree mode. 180 degrees to 270 degrees means that this will be in the third quadrant. The sine opposite over hypotenuse, negative 3 over 5. This is a Pythagorean triple, 3, 4, 5, and since it's in quadrant 3, both the sine, the opposite side, and the adjacent side will be negative. So that means that my adjacent side will be negative 4. We're going to need the sine, cosine, and tangent ratios in order to complete these problems, so let's just go ahead and find them now. I already know that sine of x is negative 3 over 5. Cosine of x is negative 4 over 5. And the tangent of x is the opposite side over the adjacent side, which would be negative 3 over negative 4, or just positive 3 over 4. The sine of 2x I'll rewrite as 2 times the sine of x times the cosine of x. So let's replace these, which are with our known values. 2 times the sine of x, negative 3 over 5, times the cosine of x, which is negative 4 over 5. So 2 times 12 is 24, 5 times 5 is 25, and this is the sine of 2x. Because I know the sine, cosine, and tangent ratios, I can use any of the 3 versions of cosine 2a given on the reference sheet. So just for this example, I'm going to choose cosine squared, or cosine of a squared, minus sine of a squared. Cosine of a, negative 4 over 5 squared, minus sine of a, negative 3 over 5 squared, which becomes 16 over 25, minus 9 over 25, and our final answer, 7 over 25. So in the first 2 parts of this example, we saw sine of 2a, or 2x, and cosine of 2x. Here it's x over 2. So I'm going to use replacement. Let's say y is x over 2. So this is tangent of y. Now, how would I get x by itself here? You would have to multiply both sides by 2. So this would become the tangent of 2y, which is our double angle formula. So this is equal to 2 tangent y over 1 minus tangent squared y. Now I've replaced the x's back into my problem. 2y is equal to x, so the tangent of x is equal to 2 times the tangent of x over 2 divided by 1 minus the tangent of x over 2 squared. Another thing to take into account, if you don't have a single variable here, but you're changing it, well, I know that x has to be between 270 degrees and 180 degrees. But x divided by 2, the range is going to change. X over 2 has to have an answer between 90 degrees and 135 degrees, placing it in quadrant 2. So which part of this equation do we know So where can I substitute a value into this equation? Before we even started any of this example, we found out that the tangent of x was 3 over 4. So I'll replace the left side of my equation with 3 over 4. And then cross multiply. Three minus 3 tan squared x over 2 equals 8 tan x over 2. Now what does this look like? Yep, once again, they've given us a trig problem in quadratic form. So we have to move everything to one side and set it equal to 0. 3 tan squared x over 2 plus 8 tan x over 2 minus 3 equals 0. Our next step, as always, is to factor our quadratic. Okay, so I get the tangent of x over 2. That was fun. The tangent of x over 2 equals negative 3, and the tangent of x over 2 equals 1/3. But remember, our tangent, or x over 2, has to be in the second quadrant. What's the sign of tangent in quadrant 2? Tangent here is negative. Therefore, my only answer is negative 3. In our second example, we're asked to solve the equation for 0 degrees is less than or equal to x, which is less than or equal to 360 degrees. Sine of 2x equals sine x. Sine 2x we replace with 2 sine x cosine x. And that equals sine of x. You may be tempted here to divide a sine x out of both sides. But if we do that, we're going to be not having all the correct answers at the end. So we'll just move the sine x from the right to the left side. 2 sine x cosine x minus sine x equals 0. And factor a sine x out. So that means sine x equals 0. And cosine x is 1/2. Well, the angles at which sine equals 0 are 0 degrees, 180 degrees, and 360 degrees. So these are the solutions that I just get from the inverse sine of 0. If I take the inverse cosine of 1/2, x is equal to 60. Cosine is positive in quadrants 1 and 4. So my other answer is 360 degrees minus 60 degrees, or 300 degrees. So all of the solutions to this problem are 0 degrees, 180 degrees, 360, 60, and 300. So do you notice what's different about this problem? Yep, we need to be in radian mode. Honestly, since radians don't come as naturally to me as degrees do, I kind of just do the whole problem in degrees and then convert my answers to radians. If you feel comfortable doing that, whichever way works for you, that's fine. So we need to determine which equivalent value equivalent expression we're going to replace cosine 2x with in order to solve this. So let's think again about quadratics. I have a sign here that I can't get rid of. So let's replace the cosine 2x with the version that has only sine. 1 minus 2 sine x squared. Okay, so moving it all to one side, setting it equal to 0. 2 sine squared x minus 3 sine x plus 1 equals 0. Factor it. Sine x minus 1 times 2 sine x minus 1 equals 0. So sine of x is 1, or 1/2. The inverse sine of x is 90 degrees, or the inverse sine of 1, is 90 degrees, which in terms of radians is pi over 2. The inverse sine of 1/2 is 30 degrees, which is pi over 6 in radians. The other quadrant, which has a positive sign, is quadrant 2. So we need the radian measurement of the angle, the reference angle, in quadrant 2. Well, 180 degrees is equal to pi, so we take pi over 6 away and get 5 pi over 6. So the three answers, pi over 2, pi over 6, and 5 pi over 6 radians. So we're going to continue with trig identities now that we know our compound angle and double angle formulas. I need to prove that tangent of 3x equals all this over here. Well, I don't have an expression that I know equals tangent of 3x, but 3x is equal to tangent of 2x plus x, which becomes a compound angle formula. So tangent of 2x plus x is equivalent to tangent of 2x plus tangent of x over 1 minus tan 2x times tan x. The next step is to replace any of these tan 2x's with the double angle formula. Two tan x over 1 minus tan squared x plus tan x over 1 minus 2 tan x over 1 minus tan squared x times tan x. So if I can get a common denominator, then I can ignore it. So let's multiply this tan x by 1 minus tan squared x over itself. And we'll do the same thing over here with this 1. Since I know everything now has the same common denominator of 1 minus tan squared x, I will ignore it and just multiply across the top. So my numerator will become 2 tan x plus tan x times 1 minus tan squared x over 1 times 1 minus tan squared x minus, then multiply across the top here, 2 tan squared x. So from here, all we have to do is distribute and combine like terms. Two tan x plus tan x minus tan cubed x over 1 minus tan squared x minus 2 tan squared x. So on the top, I'll combine these two, get 3 tan x minus tan cubed x, and in the denominator, 1 minus 3 tan squared x, which is what we were trying to prove. Let's try one more. So these are our compound angle formulas. I'll rewrite my numerator as 2 times sine x cosine y minus sine y cosine x. The denominator, cosine x cosine y plus sine x sine y minus cosine x cosine y minus sine x sine y. Well, I guess my cat wants to do some trig too. Okay, so cosine x cosine y minus cosine x cosine y, these two terms are going to cancel out. I'm not going to distribute this 2 yet because, as you'll see, I have sine x sine y minus negative sine x sine y. So in the denominator, I actually have 2 sine x sine y. And these 2's are going to cancel out. So let me split this up into 2 fractions. Sine x cosine y over sine x sine y minus sine y cosine x over sine x sine y. Over here, the sine x's simplify out. Over here, the sine y's simplify out. So you have cosine y over sine y, which is equivalent to the cotangent of y, and then cosine x over sine x, which is equivalent to the cotangent of x. And we have completed our proof.